I'm Anil Kumar. Welcome to my series on volume of solids. I hope you have understood the basic concepts. Now, we have a test question for you. The question has been taken from previous IBHL test paper. Let me thank all the students for doing so well and sharing with me their test questions. I've copied the question and then let's look into the details of solving. I hope its solution will help many of you to understand how to attempt or solve such questions. The question here is, the graph of function y equals to e to the power of x by 2. So that's the graph y equals to e to the power of x by 2 is given to you. Find the coordinates of the point P where the graph meets the y-axis. So that is your y-intercept. That's part A. Part B is find the volume of this rotation when the shaded region between the graph and the x-axis bounded by x equals to 0 and x equals to ln 2 is rotated through 360 degrees about the x-axis. You can always pause the video, answer the question, and then look into my suggestions. Now, to find the y-intercept, what should we do? Well, at y-intercept, value of x should be equal to 0. We are given y equals to e to the power of x by 2. Now, for x equals to 0, we could write this as y equals to e to the power of 0 by 2, which is e to the power of 0 or just 1. So the value of p here is what? So the coordinate p is x value is 0, the y value is 1. Correct? So that becomes the coordinate of point P. Now part B of this question is to find the volume of this rotation when the shaded region between the graph and the x-axis bounded by x equals to 0, right? So that is x equals to 0 and x equals to ln 2 is rotated through 360 degrees. And when they are rotated like this, what you get is a volume of solid of revolution, right? So how are we going to find this? Well, the concept is that the volume is equal to pi times integral of the value of the function f of x whole square times or dx, right? So the concept is that we take a small strip here, right? So the width of this strip is delta x, right? So that's the width of this strip. That is constant. Now each strip is like a cylinder. Correct? You can take a medium value of this cylinder, which becomes the radius, right? So when it revolves, it is making a shape like this, right? So the area is pi r square, right? That's the area, times delta x gives you the volume, right? The width of this, which is the height for a cylinder. And when you take sum of all these segments, slices, I should say, of cylinders, from 0 to pi by 2, 0 to ln 2 in this case, then you get the volume, correct? So I'd like you to now apply this formula and solve for part B. I'll do it on a fresh page. Okay, so the volume for this will be equal to pi times integral from 0 to ln 2. So the height any point will be given by the value of the function f of x, which becomes the radius of the cylinder, right? So r square, pi r square times delta x, which is dx. Okay, so that's how you get your volume. Now substituting what we know about f of x, e to the power x over 2, we get pi 0 to ln 2 e to the power of x by 2 whole square dx. Correct? So that gives you pi integral 0 to ln 2. So when you multiply, you get e to the power of x dx. Right? So which is pi. You can now calculate this value. E to the power of integral is e to the power of x itself from 0 to ln 2. Right? So which is pi times e to the power of ln 2 minus e to the power of 0, which is, so these are inverse functions, right? So we get 2 minus 1, right? Anything to the power of 0 is 1, so we get our answer as pi, correct? So now we can write down answer as that the volume will be pi unit cube, correct? So that is how you get the solution of such a question. I hope the steps are simple enough to understand. Feel free to write a comment, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for watching and all the best.